The next set of questions asks us to graph the rational functions in a different way. It asks us to graph them using transformations, which is what we used in Unit 2. And remember that any change to the function might move it to the left, to the right, stretch it, flip it upside down, or over the x-axis, I guess is the way you should technically say that. Okay, we're going to deal with transformations of the function 1 over x. So just a basic here. If you have this fraction and it ends up with plus a number on the bottom, what that's going to do is anything on the bottom of this fraction here is going to affect your x values, your rights and lefts. It's important to remember that it goes opposites with your x's. This plus, you would think, would make it go to the right, but it actually makes it go to the left, whatever that number is, that number of times. If you have x minus a number, that again is affecting your x values if it's in the bottom of the fraction there. And so it goes opposite. We would think that subtraction would make it go to the left, but it actually makes it go to the right. Okay, so just remember those things in the bottom, they're opposite of what we would think. If you have something added to the end or in front, okay, something not inside the fraction being added or subtracted, I'll just put number here. This is going to make it go up. Okay, so anything that's not in the fractions, that denominator, is going to affect your y values, your ups and downs. On the other hand, if you're subtracting a number, that's going to make it go down that number of times. If you have a negative in front, that's going to flip it upside down, or as we say, reflect over x-axis. Okay, and if you have a number in front, that's going to stretch it vertically, that number. Okay, by a factor of whatever that number is. All your y values you would multiply by that. Okay, so these are the basic changes that can happen. So they're asking us to use transformations of the function y equals 1 over x, which typically y equals 1 over x, the basic function looks something like this. Okay? That's what the basic function looks like. We're doing transformations on that. So as we look at this, notice there's a plus 3 down here, which if we look over here, when we add something in the denominator, that's going to move it to the left 3. So what's going to happen here is instead of our asymptotes being at 0, it's going to be over here at negative 3. Okay, so it's going to move it over this much. It didn't move up or down at all because there's no plus or minus on the end. So instead, we have this function. I meant to change the color there so we could see the difference. Okay, so again, we just used transformations. We knew it moved to the left 3. So if I want you to describe the transformation for this, we shifted left 3 units, and that's all we did. Okay, so a cleaner version of our graph would look like this. A vertical asymptote at negative 3. Part of the graph is up here, and the other part is down here. Okay, looking at this graph, notice it is in standard form. I have this basic x in the bottom, not an x squared or an x to the third, no x's in the top. So it's a transformation of my 1 over x. Let's look at any of the changes. Notice I have a positive 2 here. Okay, so remember positive, not in the denominator, that's ups and downs. It's positive, so that's going to move my graph up 2 units. I have a negative in front here. A negative in front of your fraction means that you're reflecting over the x-axis. or basically you flip it upside down, each portion. And then we have one more thing. We have lots of changes to this graph. There's a -1 in the denominator. Remember, minus, things in the denominator move it left and right. -1 is going to move it to the right 1. Okay, and I know that's kind of counter to what we would think would happen, but with the x's, it's opposite. Okay, so we've moved up 2, so we're going to have an asymptote up here at 2. Our normal graph there at 0, okay, our regular graph. And we're going to move to the right 1, so we're going to have an asymptote at +1. Okay, and normally our sections of the graph would be here and here, but we reflect it over the x-axis, which is going to flip them over those asymptotes, and we'll put them down here. Okay, so instead of here, we're down here, and then up here. So that's a sketch. Basically, they wanted to make sure you knew what was happening with each transformation. So 2, reflect over the x-axis, and right 1. Okay, here is one more example that's in standard form. Notice I just have an x in the denominator, not an x squared, and I don't have any x's in the numerator. So I know it's standard, and I can just go ahead and do my transformations. So let's look at the changes that have happened. Okay, I have a -1 here. It's not in my denominator, so that means it's changing the y's, the ups and downs. It's going to move my graph down 1. Okay, we have this negative in front of our fraction, which, remember, is going to reflect over the x-axis. And then we have this 2 on the top, which it's going to stretch it vertically. Because what it's basically doing is multiplying all of our y's by 2. I'm going to write that out. Stretch vertically by a factor of 2. So if they wanted us to sketch this on paper, the only asymptotes that's changed, it's moved down 1. So we have an asymptote at -1. We didn't move right or left, so we still have our center at 0. It's going to be flipped over the x-axis, so instead of our graph being up here, it's going to be down here, and it's going to be stretched by 2, which is just going to change our shape a bit. Okay, normally we would be down here, but we stretched over the x-axis, so it's going to be here. They're reflected over the x-axis. So there's a basic sketch of our graph using transformations, but the more important part is that you know what's happening. So it moved down 1, was reflected over the x-axis, and it was stretched vertically by a factor of 2. Okay, there are a few that are not going to be in standard form. This one, for example, is not, and I know it's not because there's an x in the top, and our standard form doesn't have an x in the top. So what we do is we divide so that we can change it into standard form. So we do long division, and we divide x plus 1 into that 4x minus 3. Now we say, okay, what do we have to do to get x equal 4x? We would have to multiply by 4. And then we multiply 4x plus 4, draw a line and change our signs. -3 and -4 gives us a -7 down here. Now x is not going to divide anymore, so that this is our remainder. And the way we write our answer is now g of x is going to look like 4, because that was our answer here, minus 7 over what we were dividing by. Okay, so you put your remainder over that denominator we had originally. This is our new function that we're going to be looking at. It's the same function, it's just been simplified, okay, by using long division. And then we say what would happen to our graph. So we look at what has happened. We have a plus 1 in the denominator here, so that means it's going to move it to the left one. Okay, we have this 4 that's added away from the fraction. I say added because it's a positive 4. That's going to move the graph up 4. We have a negative in front again, so that's going to reflect over the x-axis. Okay, so there's 1, 2, 3, and we have one more change. We have a 7, so that's going to stretch vertically. And again, when that's in the top of your fraction, by a factor of 7. So basically it would multiply all of our y values by 7. That is a lot of changes for this graph. It's going to be moved 1 to the left, up 4, reflected over the x-axis, and then stretched vertically by a factor of 7. Okay, so a lot of changes on that graph. But left 1, up 4, reflected, so, and stretched a little bit, so I'm going to have my portions in the bottom right-hand corner and the upper left-hand corner, and they're going to be stretched a bit. Last problem, I promise. So again, they want us to do the same thing. They want us to see the transformations, but it has to be in standard form first, meaning it can only have x's in the denominator to the first power and no x's in the top. So we divide. In order to get it in standard form, x goes into 3x 3 times, and I multiply and subtract and bring down the 1. X goes into 1, not at all. Okay, so this is my remainder. I write my answer as 3. I have a positive 1 remainder, so plus 1 over what I was dividing by, my original denominator of x. So I did the long division. Here is what my function looks like. What happened to the function? Well, let's look at the different parts. I have a positive 3 here, so that's going to move it up 3. I have nothing happening to the denominator, so it's not going to move right or left. This positive sign, there's no reflecting happening. All that's going to happen to this one is it's going to move up 3. So we'd have our standard function, 1 over x, typically looks like this. Okay, but it's going to be moved up 3, so all we're going to do is put a horizontal asymptote at 3, and still at 0, and there we go. That is basically, that's a sketch of what our graph would look like.